So when you see these two set of forces, endogenetic forces and exogenetic forces, typically, so the net result of these two set of forces is responsible for modifying the crust. I told you endogenetic forces are responsible for building the crust, and exogenetic or exogenic forces are responsible for removal, breakdown. Now, when it comes to endogenetic forces, now what endogenetic forces or what endogenic processes? See, this is our interior of Earth. Have a more clarity about this. So it has been mentioned that the temperature of the surface and the temperature of the center, or let's say the centermost part of our Earth, temperature will be different, obviously. So the temperature of center is more as that of the temperature of surface. Geography is comparative. When you see maximum, minimum, highest, lowest, you have to make a one common reference. Okay, so geography is always relative. Whenever you have to measure in geography that which is the highest peak, which is the lowest peak, which is the highest, or let's say largest area, which is the lowest area, so you have to make a comparison based on the same aspect. Suppose if I ask you that which is the largest water body or which is the largest lake, now if you give me an answer of a particular lake, and if I say no, that is the saline, I ask about the fresh water. So this is what the reference, this is what one set of reference which you have to use, and that should be common. So here we are taking temperature as a common reference. Okay, so temperature is greater here. Temperature is almost 4,000 degrees Celsius. And if you see the temperature of crust, so the temperature of crust is somewhere, I mean crust, we are talking about the beneath part, or let's say if you dig the crust and we dig the crust, we have only dig up to 12 kilometer, around 12 kilometer. Beyond that we are not able to dig because the temperature is very high when we are in the crust part of our. So that means the temperature is somewhere, let's say 100 to 200 degrees Celsius. Now if I ask you the temperature of which region is more, the temperature of core region or the center region is more, and the temperature of surface, or let's say towards the surface if we are moving, so we will observe a less temperature. Though it is very high, 200 degree is a very high temperature and 400 is beyond our imagination, but it's a geography, it's a study. So when we take a reference of high or low in geography, whenever there is a matter, so matter will be flow because of the development of gradient, because of the development of slope. So whenever there is a development of slope, as a result of development of slope, there will be a movement of matter, whether it is air, water, heat. So here we have what? A gradient, means slope is actually from high area to low area, means temperature is greater here around 4,000 degrees Celsius, and temperature is low here on the crust part, almost let's say T1 and T2. So when we have this kind of slope development, as a result of slope development, there will be a of matter, and here in this case heat would transfer. So when the heat would going to transfer, this heat would going to transfer in terms of Mantle convectional currents. It would going to transfer from the center towards the surface in terms of Mantle currents. We'll have a more understanding about these dimensions. I'm just giving you an overview here so that you can make proper connect these set of. So these are being called as what? Mantle convectional currents. Are being known as what? Current means there are some streams of heat which are rising from the center of Earth towards the surface, and those streams, those convectional currents are responsible for the movement, or let's say responsible for the endogenic forces, responsible for endogenic processes, responsible for the movement of crust, I would say. So these set of forces are responsible. Okay, endogenetic forces, endogenic, you can say they're the same thing. I would use these words interchangeably. Endogenetic forces are operating inside the crust because of the Mantle convectional currents, and these Mantle convectional currents are responsible for these processes. And when we have these endogenetic forces, so these endogenetic forces, because of what? Because of the convectional currents. Because of convectional current. Why there is a convectional current? Because of gradient. Which kind of gradient? Geothermal gradient. Geothermal gradient from the center towards this. Okay. So here in this endogenetic forces, based on the intensity, that sometimes these convectional current are stronger, sometimes these convectional current are slower. So when the convectional current are stronger, that will result into the sudden movement of catastrophism. And when these is being known as what? Catastrophe. And when these Mantle convectional current are slower, gradual, so they will be called as what? Slow movement or diastrophism. Called as diastrophism. So catastrophism means suddenly and diastrophism means slowly. Or in other words, you can remember about the slow movement. When the convectional current are slow, we'll have a slow movement. The convectional current are sudden, there would be what? Sudden movement. Due to the sudden movement, you will see what? Earthquake and volcanism. Wherever you will see volcano, that volcano will result into the erupting of some sort of, we can say, magma or lava. Magma when it is in the crust part, lava when it is appearing on the surface. So when lava will cool, that would modify the topography of a region, or no? When there would be an earthquake, this earthquake would going to modify the topography of a region, that somewhere it would cause depression, somewhere it would cause upliftment of the particular crust. So these are responsible for what? Creation of crust. Though for human perspective, both are what? A kind of disastrous condition. For us it is bad, but for geography, for the dynamic nature of crust, for the building of crust, for the unevenness of slope, it is required and it is a part of geography. So volcanism and earthquake, they are responsible for quick, or let's say sudden changes in the crust. So they are the means of sudden endogenetic forces. We have a role of Mantle convectional current here as well. Later you will get a more clarity. We're going to deal with volcanism and earthquake, a much deep dive manner we're going to see. Okay, but here you just focus, or you just remember one thing, that it is because of the Mantle convectional current we have what? Volcanism and earthquake. Okay, it is because of the rising Mantle convectional current the magma is appearing on the surface, or let's say lava is appearing on the surface. It is because of the Mantle convectional current there is an earthquake. Okay, and similarly when we have a slow movement, okay, when we have a diastrophism, so there will be what? Two ways in which there could be an interaction on the surface. One is what? That there might be a scenario when the two landmass, or let's say when two bigger landmass might have vertical kind of interaction. When two landmass are interacting, so they could slide up vertically. So when they are sliding vertically, they are responsible for creation of surface. They are responsible for addition of unevenness in the surface. Similarly, we could have a horizontal as well. We could have horizontal as well, means like there could be an interaction like this. You will have a more clarity about these things. Okay? So whenever we have a vertical aspect, so you will see we have an upward movement when there is a movement which is actually upside, and when there is a downside movement, that will be termed as downward one. Horizontal, with respect to the horizontal, we could have a forces of compression, means when the two landmass or rock parts or rock slabs are interacting with each other, as a result of that, compression forces will be developed, or tensional forces could be developed. So all of these are responsible for development of crust, adding the unevenness. Okay. Suppose there is a one surface area like this, and there is a weak crust. Suppose there is a weak part. So from this weak part, if these mantle convectional current are stronger, they will lead to the formation of what? Volcano. So now the topography is modified. Suppose there is an earthquake, and due to the earthquake, what happened? That this part would be like this. So there is what? Modification in the topography. There might be a possibility that these two parts would interact with each other, and they may result into the small hills. Again, what is happening? There is a modification in the crust itself. The way in which the slope is appearing, that is changing. Okay, so this is how these endogenetic forces used to state. Some are faster, some are slower, some are responsible for vertical building of crust, some are responsible for horizontal building of crust. So we have these set of endogenetic forces responsible for creation of crust, responsible for creation of dynamic crust of our Earth. Yes, the same crust which is actually being formed by endogenic or endogenetic forces, that would going to erode, that would going to under the influence of exogenic forces. Exogenic forces are the forces which are acting on the earth's surface, those who used to operate from the outside of earth. Okay, so weathering is one of the agents to facilitate exogenic force. Here we also have a role of slope, here we also have a role of movement of matter, everything is there. So we have what? Weathering. Weathering means what? That when there is a temperature and when there is a water. So the combination of temperature and water means when the temperature will increase, water will have a tendency to expand. When temperature will decrease, water have a tendency to sink. So this extension or shrinking or expansion or shrinking, this would actually resulted into the destroying of our. Suppose here we have a one mountain like this, and in this mountain we have a rock like this. Suppose here we have a, so when we have a this rock, in this small in this rock we will have a small pores. Some small pores are always there, and when we have these small pores, in these small pores there might be a water. How? Suppose there is a mountain, and when we have a rainfall, so in the case of rainfall, there is a possibility that the water drops are there. Let's say here we have a water, and when the water drops are there, these water drops would fill these pores of rocks, and when these rock, or let's say these pores would fill by water, and in outside condition, when the temperature would increase, what would happen? This water will have a tendency to expand. Okay, this will have a tendency to expand, and when the temperature will decrease, the same water will have a tendency to shrink. So this expansion and shrinking, exerting the force in the pores of rock, that would ultimately resulted into the breakdown of rock. This is how the rock used to. Okay, so this is what we used to refer as what? Weathering. The combined action of temperature with respect to water, if it is there, that would result into what? So we have a physical weathering in which there is a pure action of temperature. In chemical weathering, there is an action of temperature with respect to a certain chemicals, certain liquids. Have a more clarity about these in some later session. And I would remind you as well. And when we have a biological means by the living organism, if we have a action of temperature and water, that would result it into weathering. Suppose you are on a vacation and you are roaming, let's say in Kerala or let's say in Tamil Nadu. There we have what? Rocky part, the plateau is there. And suppose you are actually putting your, say, your food waste on a rock. So when there is a food waste on a rock, there will be what? Some organisms. Organisms will go decompose it. When organisms are going to decompose it, same organisms may release some sort of water on that rocky part. Same water would act like this, and it will lead to the breakdown of that particular part of rock. So this is what weathering, which is okay. Weathering means removal by the action of temperature and water. All right. So this is how the weathering is there. Now, one thing you should focus upon, that the weathering is basically a static or in situ process. So wherever rock is there, on that same place, weathering would take. So what if there is a mobile medium? If there is a mobile medium, then we have what? Erosion.